curious, slightly hushed. When you look at the night sky on a clear evening, the sheer density of stars suggests a galaxy teeming with activity. But when we point our most sensitive instruments at those same stars, we hear absolutely nothing. We currently exist within the observable universe, a spherical region encompassing all matter that light has had time to travel from to reach Earth. In 1950, physicist Enrico Fermi, a man who had recently helped build the first artificial nuclear reactor, realized that this massive scale didn't match our observations. While walking to lunch at the Los Alamos National Laboratory, Fermi and his colleagues were debating recent reports of flying saucers in the news. Fermi blurted out a question that cut through the conversation. Where is everybody? He recognized that our mathematical expectations are violently contradicted by our physical reality. To understand his concern, we have to look at the numbers. There are an estimated 100 to 400 billion stars in the Milky Way. Roughly 20 billion of those are sun-like stars, similar in size and temperature to our own. Astronomers focus on the habitable zone, the specific orbital region around a star where liquid water can exist on a planet's surface. Current data suggests that billions of Earth-sized planets sit comfortably within these life-sustaining regions right now. If even a microscopic fraction of these worlds developed life, and an even smaller fraction of that life built a civilization, the galaxy should be crowded with alien empires. In 1961, astronomer Frank Drake attempted to turn these staggering probabilities into a rigorous mathematical formula. He created the Drake equation to estimate the number of active, communicative civilizations we might find in the Milky Way. The formula starts with the average rate of star formation and the fraction of those stars that possess planetary systems. It then factors in biological odds, the fraction of those planets that develop life, and the fraction of life-bearing worlds that go on to develop intelligence. Finally, Drake added variables for technological advancement, radio communication, and the length of time those civilizations actually survive. According to this mathematical proof, we should be living in a noisy, crowded galactic neighborhood. This absolute contradiction, the math that says they exist, versus the total lack of physical evidence, is the Fermi Paradox. Many assume aliens are simply too far away, but even using sublight speed technology, a single expanding civilization could colonize the entire Milky Way in just a few million years. On a cosmic or geological timescale, a few million years is barely a blink. If an alien species had started when the dinosaurs roamed Earth, they would have mapped every star by now. Despite our massive efforts to listen for radio signals and look for megastructures in space, the sky remains silent. If the math proof holds and the too far away excuse fails, then an unseen force must be preventing that life from ever reaching us. This logic leads to the concept of the Great Filter, a universal evolutionary barrier that wipes out civilizations before they can expand across the stars. To go from a single-celled organism to a galaxy-spanning empire, a species must pass a series of incredibly complex evolutionary milestones. The silence of the cosmos suggests that at least one of these steps is almost statistically impossible to pass. This barrier actively destroys or halts virtually all life forms that encounter it. This concept provides a logical framework to explain why our own galaxy, despite its hundreds of billions of stars, appears completely empty. This realization turns the lens back onto humanity. We are currently navigating this same evolutionary gauntlet, which leaves us with only two possibilities. Possibility A is that the Great Filter is already behind us. Perhaps the leap to complex cellular life was the impossible hurdle. If this is true, humanity is a miraculous anomaly. We are the lone survivors of an impossible lottery in an otherwise empty galaxy. Possibility B is that the Great Filter still lies ahead of us. This implies that civilizations naturally reach our exact level of technology, but inevitably self-destruct before they can reach the stars. We already see the specific, self-inflicted threats that could act as this future filter, from nuclear annihilation to ecological collapse. Technology itself might be a guaranteed death sentence. A species might only survive long enough to unlock the energy required to vaporize itself. This leads to an unsettling realization. A dead sky is our greatest blessing. Finding the ruins of an alien empire would prove that the filter is ahead of us, and our extinction is guaranteed.